Okay, folks, welcome to the Chapter 9 review booklet. I am going to not do the entire booklet with you because there are full solutions available to this booklet in the All Resources folder. But there's a couple of questions that I'd like to go over with you that are a little bit different than the questions we're used to. And this is one of them. So typically when we've seen circuit puzzle questions like this one, we've been given the voltage at the battery, we've been given the 3 resistors, and then we go through the usual drill like we did in the resistor network assignment where we solve for RT, and then we go ahead and immediately solve for IT, and then we start solving for like all the different I's and V's, what I just call the bits and pieces. It turns out in this question, it's a little bit different. That doesn't work because we're actually not given all of the resistors. It's a bit of a change in this one. You'll notice that we're given the voltage of the battery. We're given resistors 2 and 3 at 15 ohms and 10 ohms. But then we're actually given unknown resistor 1, but we're told that we have 10 volts spent at resistor 1. It's a bit different. This is a cool question just in terms of testing some of the tools in your toolbox. Remember, the toolbox has junctions, it's got loops, and it's got Ohm's law. So let's focus on what's different, which is this right here. For resistor 1, we don't know how many ohms it's worth. That's okay. We do know, what are we looking for? We're looking for the power at that resistor. So when we look to find power, I should take a step back. We can find power with I times V, or I squared times R, or V squared over R. So if we can figure out 2 of the 3 bits of information for resistor 1, then we can go ahead and we can solve for the power there. We actually already know the voltage. So I would guess that we're probably leaning towards one of those because we've already got V. But let's see what we can do. We have 10 volts of spending at resistor 1. And remember, as soon as you see voltages and you think about spending money, that is all about loops. So the question becomes, how does spending $10 at store 1 help you maybe figure out some spending habits at another store? And loop says, go around a loop. You got to spend all your cash. Okay, fine. Let's go around a loop. Let's go on a shopping trip. There's a loop. We have $25 to spend. We spend $10 at store 1, and then we hit store number 2. So that means we have to spend the rest of our money at store 2. So loop says that the voltage that we spend at store 2 will be equal to the $25 that we left the bank with minus the $10 we spent at store 1, because you've got to come back to the bank flat broke. That's going to leave us with 15 volts. And hopefully you're staring at this and going, well, I think it's the same as this one. Isn't that loop going to mathematically be the same? Because there's another loop in there. And I would say, yeah, it's actually exactly the same. You have $25 to spend in your pocket. You spend $10 at store 1. Now you hit store 3. So it turns out that store 3 is exactly the same math. We had $25 to spend. We only hit 2 stores along the way. The first store we spent $10. That leaves us with 15 volts left to blow at store 3. So each of those is 15 volts. Now my recommendation has always been that if you know 2 out of the 3 bits of information for a resistor, that you go finish it off. So let's finish off resistors 2 and 3. We can do Ohm's law for them, and we can figure out currents. So the current at 2 is I equals V over R, 15 over 15. Look at that, 1 amp. 1.0 A for amps. And I like to label for myself currents because it helps me see what's going on with other currents in the circuit. So we've got 1 amp of current going down through resistor 2. Let's try Current 3 is V over R, 15 over 10. Hey, we've got 1.5 A for amps rolling through resistor 3. Now you want to ask yourself, the last thing that you found with Ohm's law, which was these two currents, do those two currents maybe help you figure out the amount of current elsewhere in the circuit? And the answer is, yeah, indeed it does. What we have going on is there's a junction right here. There was some amount of current coming into that junction that split to give us 1 amp going down through resistor 2 and 1.5 amps going down through resistor 3. So that means, according to junctions, we had to have had 2.5 amps going into that junction. And if you trace that back, maybe I should just show the math here. Junctions. We know that the current going through 1 was 1 amp plus 1.5 amps. That's where we got the 2.5 amps. And if we trace that back, that's how much current rolled through resistor 1. 2.5 A for amps. So what's kind of cool is for resistor 1, we now know its current is 2.5 amps. We know its voltage is 10 volts. And you can go ahead and you can really quickly calculate the power. Looks like we're going with P equals I times V. Pivot. 2.5 times 10. We are looking at 25 watts. So there's one of the questions with a little twist. I want to show you another one. Okay, let's try this one. It's a little bit similar to the last question in terms of not being able to find total resistance. So be careful here. We've got resistor 1 at 10 ohms, resistor 4 at 15 ohms. We've got identical, it says here in the question, identical resistors 2 and 3, but we don't know what they are. What they do give us, though, is they do give us the power at resistor 1. And that's something new, right? We're not used to that. My suggestion would be that if you're ever given the power at a resistor and you know what the resistance is, you know how many ohms it is, then go find your voltage and go find your current. Because you've got all those variations of power that we just used in the last equation, or the last question. We can go ahead and we can find both the voltage and the current. So I'm actually going to pause the video and just go calculate those just to save time. And then when the video starts up again, I'll have the calculations there on the screen for you. Okay, so just to save time on this video, I went ahead and I used P equals I squared R, plugged in the power, plugged in the resistance, got a current of 0.20 amps, and then I used P equals V squared over R. Notice I didn't use the current because I just wanted to use numbers given in the question in case I got it wrong. 0.40 equals V squared over 10. You get a voltage of 2 volts. Now, what we want to do is ask ourselves, how do those values help us get some other values in this circuit? Remember with current, it's nice to go and actually label it. So I'm going to say that there's 0.2 amps rolling through resistor 1. Always nice with current to think about, are there any other resistors? That's actually the full current, right? Because it came right off the battery here at 0.20 amps, turned the corner, and rolled right through resistor 1. Are there any resistors in this circuit that are also getting 0.20 amps? And the answer is yeah, there is. That 0.2 amps is going to split here at a junction, and then it's actually going to recombine at the lower junction back to a full 0.20 amps. So everywhere we've got the red is going to be 0.20 amps. And that means for resistor 4, we can go and figure out the voltage there. So let me put the voltage right here. This was 2 volts. If we find V4, that's just going to be Ohm's law. V equals I times R. So here, let's do it really quickly on the calculator. 0.2 times 15, we get 3 volts. I should be showing the calculation, sorry, we'll just save some time. Now, there's a couple of different places you could go from here. You could ask yourself, how does what are we looking for? The resistance of R2. So we're trying to figure out how many ohms that resistor is there. Sorry, I should have mentioned that right off the top. We want R2. Now, there's a couple of different places your brain could go. Number one is you could look at this and say, okay, I know that we spend $2 at store 1, and I know that we spend $3 at store 4. When I spend money, that's all about loops, right? Spending your voltage. So if we think about loops, this is one loop we could take. Shopping trip, you could go that way, and then you're back to the bank or back to the battery. We hit 3 stores along the way, and we already know how much we spent at the first store and the third store. So that middle store, you got to spend the rest of your money. So loop says that resistor 2, our spending habit, has to be 12 minus 2 minus 3. So voltage 2 is going to be 7 volts. Get that out of there. So that's going to be 7 volts. And some of you might be watching this video and saying, hey, isn't it going to be the same for resistor 3? Yeah, you're exactly right. It's the one unknown store along the way. So hey, I'll go put that in there. Why not? It's also V3. Even though we're just looking for resistor 2, it's all good. Now, the last bit of information is something kind of special in this question. I don't know if you caught it. It says resistors 2 and 3, they are identical. So if you joined me for a Zoom meeting last week, we ran into this scenario. It's actually something you had to do for question number 4 on the resistor network assignment. When current is given an opportunity to split, right here, the 0.2 amps, if it has identical resistors to go through, then it's going to split 50-50. So what's kind of cool is the 0.2 amps, we usually don't know how it's going to split because the resistors are different. But in this case, we know it's going to split right down the middle. And you're simply going to have 0.10 amps of current roll through each of them. So that means resistor 2 gets 0.10 amps. Resistor 3 would also get 0.10 amps. And now you can go and you can find resistance. Just do an Ohm's law. So I'm just going to move off to the left-hand side where I've got some space. Ohm's law is I equals V over R. This time we're solving for R. So we've got 0.1 equals, what is it? 7 over R. You're going to have a little switcheroo. And I believe when you go to solve for resistance, 7 divided by 0.1 is going to be 70 ohms. Let's double check that on the calculator just to be sure. There it is, 70 ohms. So that question kind of cool. You had to start at the resistor where we were given the power. We were forced to start there, and then it ends up being not too bad. So let's do one more together. I think it's the first one in here. Yeah, this one throws people off. So this diagram shows part of an electric circuit, and we want to know what the current is through resistor 1. This question is multiple choice, and it's multiple choice for a reason. It kind of needs to be. So let me walk you through how this one works, because this is one that students always ask about. What you want to do is figure out what the total resistance is of these 2 resistors. And quite often students will do that. They'll say, hey, 2 and 3 are in parallel. Nice direct wire connections between their tops and their bottoms. So the inverse of 25 and the inverse of 63. And then don't forget you have to take the inverse of that as well. So if we try that on the calculator, inverse 25, inverse 63, inverse that, we get 17.9 ohms. So that means resistor 2 and 3 together are worth 17.9 ohms. And resistor 1 up at the top is worth 15 ohms. So that means this bottom circuit here, or the bottom half of the circuit, is a little bit more resistant than the top half of the circuit, but not by much. So this 3 amps, when it splits, it's almost going to split 50-50, right? Because the top half at 15 ohms is really, really close to the bottom half. But because that 15 ohms along the top is just a little bit easier, it's a little bit easier because there's a little bit less resistance. And the bottom half of the circuit, it's a little bit harder for current to flow there. Then what that means is a little bit easier means a little bit more current. A little more I, right? Current wants to take the pathway that's easiest. And not all of it will, but a little bit more will. And then this pathway along the bottom's a little bit harder. 17.9 ohms is bigger than 15 ohms. So you're going to have a little bit less current. And when I say a little bit more and a little bit less, what do I mean? Well, I mean a little bit more than 50% and a little bit less than 50%. So it's going to split almost 50-50, but not quite. And if you look at the values that were given here, you can see that the top, we know it's going to be a little bit more than 1.5 amps, a little bit bigger than 50%. So that has to be, this is multiple choice for a reason, it has to be the 1.6 amps. So that means this top half, a little bit more than 1.5 amps is 1.6 amps. And then the one that's a little bit harder, well, that would be the rest of the current. That would be your 1.4 amps. So that's kind of a neat little question looking at how junctions work, right? And knowing that current will want to take, or more current will want to take the easier pathway. So I'm going to stop this video at those 3 questions. If you have other questions about anything in this review booklet, then please fire me an email. Please join me for a Zoom meeting. And if I get enough interest, I'm actually happy to make a second video where I do all of the questions if you guys want. So again, contact me via email. If that sounds like something you'd be into and you'd actually watch, let me know and I'll make a second video and get it up on the website. Otherwise, check into a Zoom meeting or fire me an email and we can work through other questions that are giving you trouble. Have fun reviewing.